This is AQA GCSE Chemistry. It is a dual award topic, which means that it is also valid for triple award students. This is part 3 of the periodic table topic. I'm going to recommend that you pause on each activity, have a go at it for yourself before reviewing the answers in the remainder of the video. So we'll jump straight in. We have got the objectives here. We're looking at group 1, the alkaline metals. And this particular video is about the practical observations that you will make when they react. So we can explain and remember how group 1 metals behave, and we can describe. We're going to explain in a later video, but describe the change in properties as you go down group 1. So let's jump straight in with the question. Why are they called group 1 metals? And they're called group 1 metals because there's one electron in their outer shell. Group 1 has one electron in the outer shell. Group 2 has 2 electrons in the outer shell, etc. We're also going to take a look at the practical. There are lots of observations that you need to make here. And the key reaction that we focus on is when you place lithium, sodium, and potassium in water. Now, we're going to talk through those observations, but it's good for you to try to remember what they are in each of the three. And I'm going to add an additional challenge. Have a think about what observations are common across all three, and then try to work out what the differences are. And that will hopefully make this a much more manageable series of facts to learn. So now you've had a chance to think about them, let's go through some of the observations that we make. Well, we're going to start with the common ones. In every single one of them, the metal floats on water. These are not very dense metals. They will all float on the surface of the water. But they don't just float when you put them in water, they move around on the surface of the water. Again, every single one of them have this in common. There's more that they have in common. They will all produce hydrogen. Now we can prove that by inserting a little spill and it will explode with a squeaky pop. That's something familiar from Key Stage 3 and that will be discussed again in future topics. We're still not done. They will also make an alkali. You will normally add universal indicator into the water before you add the metal, and you will see it turn blue or purple, indicating that we have made an alkali. Now let's have a look at the things that make the observations unique for each metal, because they don't all look the same. Lots of it is the same, but for example, lithium will effervesce. You see the bubbling coming from it. It's a vigorous reaction. It's a violent reaction. You see the bubbles forming. Now, with sodium, you don't necessarily see that effervescence in the same way. You'll see the sodium spin into a sphere, and it's actually raised slightly off the water. It's held on a cushion of hydrogen. Now, you can ignite that hydrogen to prove that hydrogen has been produced, but it looks different to lithium. Potassium, it's a different observation again. This is so reactive, it will actually ignite the hydrogen as it's produced. And furthermore, it will ignite with a lilac flame. So the big thing to take from this is that the reactivity increases as you go down the group. So now let's put that into perspective with some equations and try to link the observations to what we can see in terms of the chemical changes. I've provided here the general equation for the word and symbol form for the reactions of group 1 metals with water. And you are asked to write the word and symbol equations. Now, in the first instance, I'm not going to do the word equations. I'm simply going to say if you replace the word metal with the name of the metal, you've then got the word equation perfectly. We're going to be more focused on the symbol equations, which are far more important as we move through GCSE. But again, there's a very similar pattern here. If I replace M with the symbol of the element, I've got the equation. Instead of 2M, I have 2Li. I'm still making 2 moles of H2O. I'm making 2 moles of LiOH, and I'm making 1 mole of H2. With sodium, it's identical apart from changing the symbol of the metal. And with potassium, it's the same again. The reaction is the same, the balancing is the same. Now let's have a look how this compares with the observations. Here is the hydrogen that we know is produced every time, that we can investigate by inserting a lit spill if we collect it. In the case of potassium, it ignites automatically, we get the violet flame. In terms of the alkali that's produced, well, metal hydroxides are alkalis. It's the LiOH, the NaOH, and the KOH which will cause the universal indicator to turn purple. It's also why group 1 are called the alkali metals. The metal itself is not alkali, but it will produce an alkali when reacting with water. Okay, we're going to move on. A couple more questions here for you to try. So for this one, we're looking at the reaction between sodium and chlorine. You could be expected to do similar ones for lithium or potassium as well. But you're going to write your observations. You might need to look these up, and then a word and symbol equation. Now, sodium plus chlorine goes to sodium chloride. That's the straightforward word equation. To do the symbol equation, you are going to have to remember that sodium is Na, chlorine is Cl, but it's diatomic. All of the halogens exist diatomically. It means that the element exists as pairs of molecules. So if we're going to balance this equation, it has to be Cl2. And we've done some work on balancing equations in the previous chapter. Sodium chloride, we have to know, is NaCl. And there's more work on how you work that out in the next chapter when we look at the bonding topic. Then we need to balance it. I have got 2 chlorines, so I need 2 chlorines. I need 2 NaCl. And because I now have 2 Na, I need 2 Na on the left-hand side. Now let's think about the observations. Sodium is a silver grey solid. Chlorine is a pale green gas. Sodium chloride, common table salt, is a white crystalline solid. There's an expectation you will know all of those. And you also need to know the observation. And the observation is that it will burn with a bright yellow flame. Finally, describe the trend in reactivity as you go down group 1. We've discussed this at length actually when we looked at the reactions with water. The reactivity increases as you go down the group from lithium to sodium to potassium and beyond. We will think about why in a later video in this topic. Thank you for listening and goodbye.